In the crushing black of the ocean's abyss, where sunlight has never once pierced the water, a secret is stirring. 5,000 meters below the waves, halfway to the bottom of the Earth's crust, scientists have encountered something that defies everything we thought we knew. Down here, in a realm of eternal midnight and unimaginable pressure, they found a trace of the impossible. An invisible lifeline, a whisper of a gas that shouldn't exist in this sunless place. It's as if the darkness itself has learned to breathe. This enigmatic discovery has been dubbed dark oxygen by those who first witnessed it. It's a phenomenon so unexpected and profound that it could upend our understanding of life on Earth. How could the breath of life emerge in a world with no light? What hidden force is at work in the deepest recesses of the sea? The journey to find answers begins with a mystery that sat unnoticed on the ocean floor until now. It all began not as a grand quest, but as a routine expedition. In 2013, marine ecologist Andrew Sweetman and his team journeyed to one of the most remote regions of the Pacific Ocean, the Clarion-Clipperton Zone. This is a sprawling abyssal plain stretching between Hawaii and Mexico, an underwater expanse larger than the country of India. Far from any continent, the seafloor here is littered with strange lumpy rocks known as polymetallic nodules. These potato-sized mineral riches, laden with cobalt, nickel, manganese, and more, have long tempted deep-sea mining companies looking for treasure in the darkness. Sweetman's mission, however, was not to hunt for metals. He wanted to understand how life survives in this cold, dark desert of the ocean floor. Aboard a research vessel rolling on the open Pacific, Sweetman's team lowered a special chamber down nearly 5 kilometers to the seabed. Inside this device, a small section of the ocean floor, sediment, water, and a few of those metal-rich nodules was isolated from the rest of the sea. The plan was simple: measure how much oxygen the creatures and microbes on the seafloor use up. In the perpetual night of the deep ocean, with no new oxygen being made, any life down there must slowly consume the limited supply that drifts in from above. The expectation was that within the sealed chamber, oxygen levels would steadily drop over time, reflecting the respiration of whatever tiny organisms were present. But when the chamber was retrieved and the readings analyzed, the scientists were stunned. The oxygen levels inside hadn't fallen, they had risen. It was as if the empty darkness inside that container had somehow begun to breathe out oxygen. Sweetman was convinced it had to be a mistake. Instruments can malfunction after all, especially under the immense pressure of the abyss. Puzzled and skeptical, he and his team set the baffling data aside, suspecting their oxygen sensors were faulty. For years, the mystery lingered at the back of their minds, unexplained and unresolved. It wasn't until 2021, on a return trip to the same region, that the enigma resurfaced, and this time it refused to be ignored. Armed with new equipment and a determination to get to the bottom of the puzzle, Sweetman repeated the experiment. Again, he sealed off a chunk of the seafloor in a dark, airtight chamber. Again, the oxygen began to climb where it should have dwindled. No matter what the researchers tried, new sensors, different methods, the readings told the same unbelievable story. Something on the deep ocean floor was producing oxygen. Incredulity gave way to excitement as the team realized this was no instrument error or fluke of mixing waters. It was real. They had stumbled upon an unknown phenomenon hidden 5,000 meters beneath the waves. Now they faced an even bigger question: what on earth could be creating oxygen at the bottom of the sea? To truly appreciate the strangeness of oxygen appearing in the abyss, we need to remember how Earth's oceans get their oxygen in the first place. Almost all the oxygen we breathe, and the oxygen dissolved in seawater, comes from sunlight and life at the surface. In sunlit waters near the top of the ocean, tiny plants and algae, along with bacteria, perform photosynthesis. Using energy from the sun, they turn carbon dioxide and water into organic matter, releasing oxygen as a byproduct. This process floods the upper ocean and atmosphere with the life-sustaining air and water that animals depend on. But sunlight is feeble and short-lived in the ocean. Even on the clearest day, meaningful light only reaches down about 200 meters. Below that is a realm of darkness where photosynthesis simply can't happen. So how does any oxygen get to the deep sea at all? The answer is a slow, planet-spanning circulation. At the poles, icy winds chill the ocean surface, and surface waters become packed with oxygen from the atmosphere. This cold, dense, oxygen-rich water sinks and creeps along the seafloor, inching its way through the world's ocean basins over centuries. In this way, a bit of the surface's life-giving breath is conveyed down into the abyss, providing a thin lifeline for creatures of the deep. Over hundreds or even thousands of years, this conveyor belt of thermohaline circulation gradually delivers oxygen to regions that sunlight never touches. Yet the oxygen that reaches 5,000 meters deep is precious and sparse. Life in the abyss is adapted to make do with meager rations of it. And in isolated pockets, sealed chambers, like the one Sweetman used for instance, there should be no new oxygen coming in at all. Any bacteria, worm, or scavenger trapped inside would steadily use up what little oxygen was there. That's why Sweetman expected his measurements to show a decline. Instead, he found oxygen increasing, as if an unseen oxygen factory had switched on far below the photic zone. It was a result so outlandish that it challenged a fundamental assumption, that in the deep ocean, oxygen can only be consumed or imported, never created anew. Sweetman and his colleagues finally had a suspect in mind: the nodules themselves. Those odd black rocks, it seemed, might not be inert at all. Could the very treasure the mining companies sought also be a hidden engine creating oxygen in the dark? The idea was as wild as it was thrilling. If true, it meant that lifeless mineral stones were somehow behaving like batteries on the ocean floor, using chemistry alone to split water molecules and release oxygen. The team coined the term geobattery for this concept. Inside each nodule lies a cocktail of metals: cobalt, manganese, nickel, copper, and more. When submerged in salt water, those metals can undergo spontaneous electrochemical reactions. In simple terms, they might generate an electric current, just as two different metals in a battery produce electricity when connected by a circuit. And with electricity, something extraordinary can happen. Water can be broken apart into its basic elements. It's a process known as electrolysis, an elegant word for cracking H2O into hydrogen and oxygen gas. In industry, electrolysis is done deliberately by running a current through water. But here, it could be occurring naturally, on tiny scales, atop an endless field of rocks at the bottom of the sea. To put their hypothesis to the test, the researchers devised careful experiments back on the ship and later in the lab. They collected samples of the seabed, including several nodules, and made sure to eliminate any living organisms in those samples. They sterilized the water and sediment to rule out microbes as the source of oxygen. Then they sealed everything in airtight containers filled with deep ocean water. If oxygen still rose inside these lifeless closed systems, the source had to be chemical, not biological. The results were undeniable. Even in complete darkness, with no life and no outside input, oxygen levels in the containers slowly climbed. Something in the samples was indeed producing oxygen, just as it had in the deep ocean. When the nodules were removed, this effect vanished, implicating them as the culprit. Further analysis revealed that the nodules were giving off a small but measurable voltage, about 0.9 volts between certain points on a nodule surface. That's nearly as much electrical potential as a standard household battery cell. It approaches the threshold needed to split water into hydrogen and oxygen. In essence, the researchers found that each little rock was functioning as a miniature power source, pumping out tiny drips of oxygen into the surrounding water. They had confirmed it. The polymetallic nodules were creating dark oxygen on the ocean floor. The realization that rocks can create oxygen in the abyss doesn't just rewrite textbooks, it also raises urgent practical questions. If the deep ocean floor has its own secret trickle of oxygen, even a small one, could it be a lifeline for creatures eking out an existence down there? Perhaps certain microbes, worms, or other deep dwellers congregate around nodules not just for shelter, but to sip at the faint wisps of oxygen they provide. In an ecosystem where every breath is hard-earned, even tiny oxygen oases could make the difference between survival and suffocation. We have to wonder, by disturbing these nodules, would we be extinguishing an invisible support system for life? This question comes at a critical time. Polymetallic nodules are at the heart of a growing industrial interest. Mining companies see them as a $3 trillion treasure trove of metals essential for batteries and renewable energy technology. The promise of electric cars and green power has driven a modern gold rush to the ocean floor. But the discovery of dark oxygen shines a stark light on what might be lost in that pursuit. Tearing up the seabed to scoop out nodules could mean destroying habitats that we barely know exist, and possibly erasing this newly found oxygen source before we even fully understand it. The deep ocean is not a lifeless void. It's a living realm that evolved over eons around these mineral formations. Remove the nodules, and you remove an entire foundation of that ecosystem. Scientists warn that any biodiversity and functions tied to the nodules would vanish, perhaps for millions of years, because that's how long it takes for new nodules to reform. In essence, deep-sea mining could irreversibly rob a corner of our planet of both its rare metals and its rare biology. The implications stretch even further. Consider the climate. The deep sea plays a quiet role in regulating Earth's climate by locking away carbon in its sediments and circulating nutrients. A mass disturbance like mining could kick up plumes of sediment, releasing stored carbon and disrupting this balance. We might inadvertently accelerate climate change by undermining one of Earth's natural carbon sinks, an ironic outcome for an activity meant to support green technology. All these unknowns and risks highlight a simple truth. We are only beginning to grasp how the abyssal environment works. Many in the scientific community are urging caution, even calling for a moratorium on deep-sea mining until we learn much more. After all, it would be a tragic irony to damage the ocean's hidden life support systems in the very name of sustainability. Beyond the practical, this finding touches on something profoundly philosophical. It challenges our assumptions about life's requirements and Earth's own history. Could this phenomenon of dark oxygen have been a spark that life on Earth used long ago? Imagine the primordial oceans billions of years in the past. Life was just emerging, and the world was mostly anoxic. Perhaps on some ancient seafloor, before plants or algae existed, natural electrochemical reactions in mineral-rich rocks produced tiny pockets of oxygen. Could early microbes have exploited those pockets, using a breath of oxygen to gain an evolutionary edge? It's a speculative idea, but one that has scientists curious. Maybe the seeds of life didn't just rely on lightning or hydrothermal vents, but also on the gentle electrical breath of stones beneath the sea. Then there's the question of life beyond our planet. Oxygen in a distant world's atmosphere has long been seen as a possible sign of living organisms, of alien forests or algae exhaling into the sky. But if oxygen can also be created by non-living processes deep underwater, how might that change our interpretation? For instance, consider the dark oceans hidden under the ice of moons like Europa or Enceladus. In those lightless waters, could there be geobatteries at work, dribbling out oxygen and perhaps nourishing alien microbes? The discovery in Earth's ocean shows that a planet or moon doesn't need sunshine and green plants to have oxygen in some niches. It broadens our imagination. Life might find a foothold in places we once thought impossible. And conversely, a planet's oxygen might not always be the smoking gun of biology. It could be the signature of geology at work. Ultimately, what we've learned from this deep-sea mystery is a humbling lesson. Our world still holds secrets that can surprise us, even in the most inhospitable corners. It reminds us that life and the conditions that support it are more diverse and inventive than we ever imagined. And it calls on us to approach the unknown with both wonder and caution. Our journey into the depths must now surface, but we emerge with a renewed sense of awe. The ocean's abyss, once thought silent and still, has revealed a breath, a quiet hint that even in absolute darkness, the story of life is not yet finished. This mysterious oxygen rising from the seafloor is a reminder that there are forces at work on our planet that remain barely understood. It urges us to keep questioning, to keep exploring the unseen corners of Earth with open minds. What other marvels wait down there in the dark, whispering to be discovered? In the end, the discovery of dark oxygen is more than a scientific surprise. It's a poetic reminder of nature's boundless creativity. It shows that life's canvas is far broader than the thin layer of sunlight we typically imagine. There are chapters of Earth's story written in light and in darkness, in shallow reefs and in the deepest trenches. And each discovery, like this one, brings us one step closer to understanding the full narrative. As we venture forward, we carry with us a sense of wonder and respect for the deep ocean, a realm that, even after all our advances, remains a final frontier. The abyss has given us a glimpse of its secrets. It's up to us to listen, to learn, and to protect this wondrous world that still has so much more to say.